In the previous tutorial video, we show you how you can verify the truth table for the various logical operators. So conceptually, you should really understand these three truth tables very well. You don't need to memorize them, but just understand under what circumstances can you get true for conjunction, and under what circumstances can you get false for disjunction, right? Just follow the reasoning that I did in the previous video before you go on. Okay, and also we did the some simple programming over here by declaring the Boolean type and try to apply the logical operators, explanation mark, and also we got ampersand, also we got vertical bar for the various logical operators. Just make sure you review them before you go on with the current video. Okay, so now for this video, we're going to show you some simple applications, some very common ones to show the usefulness for the logical operators, okay, to combine relational operations. Okay, so now what I would do is let's start with logical negation and see a simple application for that. Let me just create a new class over here and say new Java class. Okay, so let me just say logical operation app. Okay, 1. Okay, logical operation app 1. Okay, just an application. Okay, and then choose a main method text box and then checkbox, and then you say finish. Okay, let's now do the following. Let's say this is what we want to do. Okay, develop a console application that determines if the users enter the user entered integer is positive, which means strictly larger than 0. Okay, and let's see how we can do it. Basically, enter some integer and want to check to see if it's strictly positive. Okay, let me show you how you would do it without using logical operator, and then I'll show you an equivalent way of doing it using logical operation. Okay, that's what I will show you, especially logical negation. System.out.println. Over here, I would say enter an integer. Okay, so that means what we're gonna do is we're gonna say integer I is assigned to input dot next. Oh, sorry, I forgot to declare the scanner. Okay, every time make sure the first thing you do is if you're using user input, you must declare the scanner. Scanner, okay, control space to really import it. Input is new scanner system.in, and system.in simply means the keyboard. And at the end of your program, you're gonna say input.close. Okay. Okay, input.close. And now over here, we're gonna say input.next int. Okay, that's what we have. Basically, we're reading some input integer from the user and then store that in I. So we covered that in the previous video. You can refer to that if you're not so confident with this line. Okay, so basically, this is what we want to do. System.out.println. So we're gonna have some. We're gonna do the processing and also the console output at the same line. Okay, the integer, the number. Let's say the number you enter was positive. Okay, and now how can we do that, right? So what we can do is we can simply say I is strictly larger than 0, right? That's one way to do it. Okay, you can either do it this way or you can use a variable to store the result. Okay, let me also show you how you can do it. Okay, so this is solution 1. You know what, let me just make it into comments. Okay, so now let me say Boolean is positive. And by the way, remember, always when you want to declare a variable, make sure if it is a compound word, the first word is all lower cases. And starting from the second word, it should be capitalized. So that's the naming convention for Java. Try to follow that. Okay, is positive will be I is strictly larger than 0, right? So that's something we also cover in the relational operations video. Okay, so now what we can do is you can do something very similar. Okay, you can either do this line or you can do this line basically. And now we can say is positive. Okay, either way will work. Okay, so now let's do it now, and then we will show you how you can use logical negation to achieve the same thing. So now let's do it. Enter integer. For example, if I say 0, 0 larger than, so as soon as I say enter, that means I will be store 0. And then over here, 0 larger than 0 will be false, which means it is not positive. Okay, let me go back to the console over here, and then you can say enter. It would say the number you enter was positive. That's false. It is not the case. Okay, let me do another run for you. And the integer, if I say 2 over here, the number you enter was positive. It is true. Okay, and now let me do once more. So negative number minus 10. It is not positive. Okay, so hopefully you see the idea. Okay, let me do one more to make sure. 10. Okay, that should be true. Okay, so now you see all the cases. Okay, so now what I want to do is I want to show you this. I want to use some logical negation to show you something that will be just equivalence. Okay, so now what I would do, how about this? To really avoid confusion, I would say rename this 1.1. Okay, actually your class name cannot contain point. Okay, what about 1.1a? Okay, that's what I would do. Okay, highlight the class, right click, and then say refactor. So now we can rename the class. Okay, I want to show you basically two versions, 1a over here, and then continue. Okay, now I'm gonna copy this class and get 1b. Okay, so now if you click on this, and you can right click and simply say copy. Okay, and then right click again and you say paste. So now I will call that 1b. Okay, now in this version 1b, I'm gonna achieve the same external behavior. However, I'm gonna do it slightly differently. Okay, so basically think about this. Let's do this. Let's understand this. The logical negation of I larger than 0, which is exactly over here, is not the case I larger than 0, right? Okay, so this is something we'll try to explain to you later in the course to actually to give you a little bit more insight into the mathematical form. Okay, but now one way to think of this is like this. What's the logical negation for I larger than 0? Think it this way. If you think about, this is the number line. Okay, there's a number line over here. So let's say this is the point 0. Okay, when you say I is larger than 0, so what are you talking about? When you say I is larger than 0 over here, you're talking about all this part over here, right? I is larger than 0. Everything that's to the right and does not include 0. So now if I try to do the negation of I larger than 0, so if I say not the case, and then parentheses to make sure it is applied to the result for I larger than 0. In that case, if I try to do, so not the case that I is larger than 0, it's going to be basically everything that's not covered by the blue. Okay, including 0 and then everything to the left. So what is that equivalent to? It is equivalent to basically this. It's equivalent to I less than or equal to 0. Okay, hopefully that's quite intuitive to you, so I don't need to explain any further. Basically, whenever you want to have, for the negation of larger than, you got less than or equal to. What about if I say, what would be the negation for I less than 0? It would be just equivalent to I larger than or equal to 0. Okay, you can do the same exercise on the number line. I'll relay that to you. Okay, so hopefully that makes sense to you. So now what I would do is, and over here, for I less than or equal to 0, I can think about as, you can simply, I can just say it's less than or equal to 0. Okay, that's something we already understand conceptually. Okay, I'm gonna actually do this one here, and then I'll show you how I can create some equivalent program using logical negation. Okay, so now enter integer over here, the same as before. Okay, is which is equivalent to I less than or equal to 0. Okay, so now let's now say rather than is positive, what I would do is I would say less than is less than or equal to 0. Again, you can see the naming convention over here. This is a compound word. This is the first part of the compound word. So this is the all in lower cases. And starting from the second word, you can see the second word is capitalized, third word is capitalized, and so on. It's capitalized, right? Capitalized, capitalized, okay? So now, less than or equal to 0, less than or equal to 0, like that. So now, when I say the number you enter was positive, which is I larger than 0, which means conceptually, right? So now we know that its negation will be just I less than or equal to 0. So now, how do I get back to the original one? Okay, I can simply basically double negation. Double negation gets you back to the original one. So what I can say is not the case is less than or equal to 0. Okay, this one is a little bit like a logical exercise over here, right? So basically, basically it's like this. This is what we are doing. Okay, you kind of understand how I illustrate in the logical negation on the larger than on the number line. Okay, thinking this way. Okay, thinking this way. We know that what we want to check in version number 1 in app 1 is I larger than 0. Okay, and we know that conceptually the negation of that is the negation of I larger than 0 is equivalent to I less than or equal to 0. Okay, so I less than or equal to 0 and I larger than 0, they are not the same expression, right? They're simply negation of each other. So now, how can I rewrite this original expression in a way that is equivalent? What I can do is I can take the negation of its negation. Okay, so now you can think about the logical negation for I less than or equal to 0. Let's draw that on the number line over here. If you think about this is number line over here, and then this is the original line 0. Okay, so now this is going to be included. Now think it this way. So now if I have over here, let's say I less than or equal to 0, I know that it's going to cover exactly this part over here, right? I less than or equal to 0. Okay, so this is the orange part. Now, if I try to do the logical negation for that, apply the exclamation mark. It's going to be just the other half of the number line. So what will be the blue part? So the blue part over here, you can see that this one over here, this part is not the case I less than or equal to 0. And now compare this blue part over here with this blue part over here. This blue part simply means I larger than 0. Okay, now you can see that this one over here is completely equivalent to this one here. And the way we draw diagram is we're doing a proof. Okay, so now please really try to follow this video a few times maybe if necessary. You really want to understand. So sometimes to really write something, you may have different ways to write it. Especially you can just use double negation, right? So this is something called double negation. So from here to here is negation. And from here to here is the second negation. After double negation, we get something over here that's completely equivalent to the original one. Okay, that's the idea. Okay, so please make sure you understand this part. Double negation. Okay, it might be something you already understood from your high school logic or math, but now we're just doing that in programming. Okay, we're just applying math into programming. The number you enter was positive, and then I'll say it is simply not the case. It is less than or equal to 0. And it's less than or equal to 0 is logical negation of larger than 0. Okay, that's again, it's double negation. And the number you enter was positive. You can try this one as well. What I will do is I'll write it down for you. You can think about what we are trying to do over here. If you say, I'll try both together with you. So now double negation, I'll put it here, and then you can uncomment that and then try. Basically, if you do this is the original one, I larger than 0. First of all, apply a negation to it. You get I less than or equal to 0. And then the negation of I less than or equal to 0 will be I larger than 0. Okay, that will also work. Now, let's try to execute the code and see if things will work just the same way. And what I will do is I will execute the program over here, enter integer. If I say 10, okay, it was positive, it's true. And what about if I say, write it again, if I say -5, it will be false, okay, which is also as expected. Also, if I say 0, 0 is not positive, so it's false. Okay, let's try to trace the program a little bit and see what happened. Okay, so what I will do is I'm gonna again take a screenshot of this code over here, and then I'm going to illustrate to you. Okay, so now what I will do is I'll simply just get this block of code over here and then show it to you how it can be run. Okay, so now let's go to a new page over here and let's try to see that. Okay, let's try to copy for the clipboard. Okay, over here. So now let's see how this can be traced. Okay, so now enter an integer over here. So now what I would do is, let's do it this way. Let's do different tracing. Okay, let's do different inputs. Let's say the first, let me use green over here. So the first time we do this, that's case number 1. Let's say enter some integer over here, right? So what you would do is enter integer. Let's say if the user enter some integer here, let's say they enter 10, for example. If they enter 10, that means I is going to store 10. Okay, I is going to store 10. And then if I stores 10, what's going to be the value for this Boolean variable over here? Because if I is happens to be 10, 10 less than or equal to 0 will be false. So that means false is going to be stored in less than or equal to. And then false is going to be this value over here. Okay, so we know that this is going to be false. And we are also going to apply a logical negation to it, which will be true. Okay, that means the number you entered, which is 10, was positive. Eventually it's going to tell you true. But you just have to follow through this kind of a double negation logic over here, right? Let me do one more trace for you. Okay, let me just copy the same block of code, and then let's have a different run. What about I simply have another run? Okay, so we simply say enter an integer over here. Let's say this time the user enter another integer, let's say -5. And what would be the expected result? You would say the number you enter was positive should be false eventually, right? So now I is going to store -5, as we know. Okay, and then let's see what's gonna be the value for I over here. Of course, it's gonna be -5. -5 less than or equal to 0 would be simply true, right? Because -5 is a negative. So -5 less than or equal to 0 would be true. And now that means less than or equal to 0 is going to store false. Okay, so far so good. However, the expected output from the console would be it is positive. So now that's where the second negation will come into place. So now we know that so far we know that it's less than or equal to 0 is going to store false. And don't forget, we also apply a second negation over here. And second negation is going to flip false into true. Okay, so this is the final result we'll get. So you will say the number you enter, which is -5, was positive. It is going to be, did I do something wrong over here? I beg your pardon. Actually, can I just go back a little bit? I make a mistake over here. Basically, okay, let me just tell you where the mistake was. So when we said over here -5 less than or equal to 0, it should be true, right? And of course, true will be stored inside this particular Boolean variable. I beg your pardon, that's my mistake. So now over here, so that means true is going to be stored in is less than or equal to 0. Okay, that's the only part I made a mistake. Okay, please just correct that. Okay, so this is the true result, and true is actually stored into this Boolean variable. Okay, so what we will do over here is, okay, let me just do this one again. Okay, just make sure you can understand it properly. So now we know that is less than or equal to 0 over here is simply just going to be true, as we said over here, and that's actually came from over here, right? And now we apply the second negation over here, so that means we're going to negate true to false. So this is false. And now we know that the number you enter is -5 was positive, that should be false. Okay, so again, my apology for the mistake, but please just make sure you can trace these two cases. One case you return true, and one case you return false. And notice that the expected output, when the expected output is actually true, and the logical negation that we are trying to calculate would just be false because we apply a second negation. When the expected output is actually false, but the logical negation for that is simply just true. But since we apply a second negation over there, so the result will still be okay. Double negation will go back to the original result. Okay. So it's really important for you to understand this kind of logic for double negation. I think that will be the simplest example to illustrate. Okay, and then in the next video, we'll show you applications for the conjunction and disjunction.